Hey everyone, and welcome to this pre-calculus course. This is the first video, and we're going to cover functions and their notation. And we'll also talk about inputs and outputs and independent variables and dependent variables, and we'll even briefly talk about domain and range, but we'll talk about that more in depth in a couple videos. So to get started, I want to kind of explain what a function is, and a definition of a function is basically a relation between one input and one output. So when you put one thing in, only one thing comes out. That is a function at its core. So I like to explain this using a machine analogy. So we've got this little function machine, and we'll put in an apple, and out comes apple juice. And we can put in an apple, apple juice comes out. And we could even put in a red apple, and we'll get apple juice. And we could put in a green apple and still get apple juice. Like we could put in two different inputs because these are what we're putting in. So these all right here are the inputs that go in. And we could put two different ones in and get the same output. And these are all outputs because these are what come out. So you could put in a red apple and get apple juice. You could even put in a yellow apple and still get apple juice. You could even put in a banana and probably get apple juice. But for this case, I'm just saying you put in a banana, you get banana juice. I've never had it, but if it exists, it's probably good. Anyway, so that's kind of how functions work. So for example, like what's not a function is if we put in an apple and not only did we get apple juice, but we got orange juice too. That can't happen because we have one input come in and we have two outputs. That's not a function, that's just a relation. So we want to be able to tell what a function is or isn't. So one input, one output. And I don't want you to confuse that with one-to-one functions. Those are a type of function, and one-to-one functions are one input for one specific output. So if you plug in one, you always get two. If you plug in one, you're not going to get, or like if you plug in two, you won't get two also. Like one input and one output are together. So that's a one-to-one function, and those are a type of function. But a function at its core, one input, one output. That's it. Okay, so we can go ahead and push this out of the way. And we'll go ahead and go over some examples to kind of hit this home because it's important to know if it's a function or not. So we can start with these two sets. So we have these relations here, and we want to know if they're a function or not. So starting with set A, we have these coordinate points, and all we're going to do is look at the inputs. And we'll look at the inputs, and then we'll see if they each have their own, or if they each have, their own output. So we've got, let's change colors here. So we've got 1, 7, 3, and -1. Right off the bat, we know it's a function because we have different inputs. And so even if the outputs were the same, it's like the apple juice. We could have different inputs. We could have a red apple, a green apple, a yellow apple, and a purple apple. And they could all have apple juice, apple juice, apple juice, apple juice. They could all have the same outputs. But if the inputs are different, it doesn't really matter what the outputs are. But we can still check. I mean, we've got 2, 11, 8, and 11. So we have two of the same outputs, but we have two different inputs. It would be a problem if this one here, if this 3 was -1, if we had two of the same inputs, -1 can't produce 11 and 8. You know, that red apple can't produce orange juice and apple juice. That's kind of what we're looking at here. So I hope that makes sense to you. So all of these are different inputs, so yes, it's a function. Let's look at set B. Looking at the inputs again, we've got 4, -3, 4, -7. So we have two of the same inputs. Now, if their outputs aren't the same, then it's not a function. If the red apple is giving orange juice and apple juice, it's not a function. So this output is 5, and this output is 8. So they're different. One input has two outputs, the one input being 4, and the two outputs being 5 and 8. It's not a function. Now, that's just with, coordinate points. We can do this with equations or, these expressions too. So now what we want to look for with these problems is a notation issue, like something that will guarantee that we will always get 2 answers out. That's kind of the giveaway that we know that it's not a function. So here, we can plug in numbers if we want and see if we get one output, one input, one output. But this is the equation for a linear line. And so we know that there's nothing here that's obvious that'll be like, okay, if I plug in this number, if I continuously plug in numbers, I'm going to continuously get 2 numbers out. So this one, we know it's a function. Same thing here. Let's solve for y, because that's the best way to know if it's a function, is if you have your dependent variable separated. And let's go over independent and dependent variables. So back to the machine, inputs are independent and outputs are dependent. So what does that mean? Like, if we bring back the machine, these are our inputs. These are our outputs. And these depend on whatever's plugged into the machine. So these change depending on what comes in or out. So if I plug in a banana, I'll get banana juice. But if I plug in an apple, I'll get apple juice. So the outputs depend, or are dependent variables. And these are independent. Now, I mentioned domain and range. We'll talk about that more in a couple videos, but to kind of get our feet wet, the domain is the set of inputs. So all of these inputs grouped together are called the domain. So the domain is a set of inputs, like that. And so our range is our set of outputs. All of these in a group is our range. Put that here. So that's all of those. All of those are the range. So back to our example, is we want the dependent variable y by itself, where x is the independent variable. We can plug in whatever we want as long as it's in the domain. We can plug in whatever we want in the independent variable, and this y will change depending on what we get. So let's separate y. We'll subtract 3x over, and we'll have 2y equals minus 3x plus 10. And then to get y by itself, 2 is just multiplied by y, so to undo that, we'll divide by 2. And we'll do that to all of the terms to keep it even. And then this will give us y negative 3/2 x plus 5. So now we've got y by itself, and we see here there's no obvious notation issue, and we'll see what notation issue we run into here in a minute. But here, if you plug in one number, you'll get one number out. Even if this was like x squared, if you plugged in like 2, for example, you won't get 2 outputs. You'll have 2 times 2 is 4, and that's still one number. And then 4 times negative 3 over 2 is what, like negative 6? And then like you'd have negative 6 plus 5 is negative 1. So you'll get one output. So this is still, this one here is still a function. Now square roots kind of get tricky. It kind of gets tricky with squares and square roots. So this square root here is positive. We don't add a plus or minus here. Sometimes it's easy to confuse those. We only want to add a plus or minus when we have to draw the square root, and I'll show you that in a minute here with this example. But here, we're just going to leave this as positive, and when we look here, it doesn't really matter what number we plug in, we'll get one output. One number in, one number out. I mean, if we plugged in, even if we plugged in 1/4, let's say x was 1/4, so we had square root of 4 times 1/4 minus 1. So 4 times 1/4 is 1. So I have 1 minus 1, and that is the square root of 0. It's okay, you can take the square root of 0 and you just get 0 out. So we plugged in one number, we got one number out. So this one, also a function. Where it really gets kind of messy is when we have to take the square root. So let's solve for y here like we did up above. We'll subtract x squared. And so now we have y squared equals negative x squared plus 4. So now we've got a square power, so to undo that we do the square root. And then we'll do this on both sides. And because we were the ones to draw the square root, that's when we add the plus or minus. So we drew the square root, these cancel, we draw the square root here, so we add the plus or minus. And you don't need to do it to both sides because that's just redundant. But you just need it on one side to indicate that you have a positive and a negative answer. And that right there is the troublesome guy we were looking for. This is the notation issue that we were looking for, because whatever number we plug in, we're going to have a positive version and a negative version of that number. And so therefore, whatever number we plug in will always have two answers, a positive and a negative one. So this function here is, or excuse me, this is not a function, is what I should have said. This equation here is not a function. So plus or minus is the notation issue you kind of want to look for up to this point to determine whether it's a function or not. So this example here, thankfully we don't have a y squared, so we know we won't be taking the square root, so we could probably just right off the bat say, yes, this is a function. But still we can solve it for y to make sure that we're not missing anything. But here we've got y in both terms, and we don't have any y's over here on this side. We have all of our y's isolated and all of the non-y terms on the other side. So that's perfect, we're in good shape. So we can factor out a y here, end up with x minus 6 times y. We have x minus 5. So now y is just being multiplied by this whole binomial, so we can divide that to move it to the other side. That cancels. So then we're left with y equals 3x minus 5, x minus 6. So here we can see there's no square root, there's no plus or minus that like we're dealing with. Like even if there was a square root, it could still be a function. It's the plus or minus that we're looking for. And we don't have any of that, so yes, this is a function. And you may wonder, like, okay, well, what about 6? If we plug in 6, we'll end up dividing by 0, and we can't do that. That causes problems, or it's undefined. So that's where the domain and range come into play. So the domain of this function doesn't include 6, so we can't plug in 6. And the domain, remember, is those set of inputs. So like on this machine, our inputs were all fruits. So maybe for this machine, the domain is only fruits and we can't plug in vegetables. So if I try to plug in broccoli, it'll be like undefined, you know? So that's kind of the same thing that we've got going on here. 6 is that vegetable or that broccoli that is not part of the domain, so it's undefined. So for everywhere that it is defined in its domain, it's a function. So that's why this is a function. Whatever number we plug in, we won't ever get two outputs. So that's kind of the synopsis. That's kind of the synopsis of functions and their notation, and with inputs and outputs, independent and dependent variables. Our next video, and well, yeah, the next video in this sequence will be more about different ways we can display functions using tables and graphs, and how we can evaluate functions, and a little more about that. So stay tuned, because that'll be the next video, and thanks for watching.